Hello. Welcome to physics. Today we are discussed about the electrostatics. And electrostatics is a basic chapter, most fundamental chapter of physics and also most important for JEE exam and also NEET exam. Here we are discussed about the basic property of electric charge and concept of Coulomb force and also different numerical problem based on Coulomb force. And this is the first video lecture of electrostatics. Then let us start one by one, step by step, each concept of the electrostatics. Main topic for discussion, electrostatics. Initially we are discussed about the basic property of electric charge. Basic property of charge, right? Initially, suppose that this is a body, suppose that this is a sphere, and inside of sphere amount of positive charge due to protons, right? Amount of positive charge due to protons equal to amount of negative charge due to electrons, right? And total charge of the body is equal to 0 because value of positive charge is equal to value of negative charge, and positive charge due to protons, negative charge due to electrons, and total charge of the body is equal to 0, mean no any charge of the object, because amount of positive charge is equal to amount of negative charge, no any charge. But when electron transfer from one body to another body, any method like by friction method, by conduction method, by induction method, when electron transfer from one body to another body, then both body individual becomes charged. First is a positively and second is a negatively. Suppose that this is a first object and this is a second object. Initially both body, this is a first and this is a second, mean A and B. Initially body A is a neutral and body B is a neutral, as like this situations. But when electron transfer from body A to body B, as like this, when electron transfer, some electron transfer from A to B, then this is a donor, mean here positive charge, mean body A becomes is a positively and body B becomes negatively because this is a acceptor, and value of positive charge of body A equal to plus NE, right, and value of charge of body B equal to minus NE, and N is a transfer number of electron, right, mean value of transfer number of electron from body A to body B, and N is a complete integral value, as like this 1, 2, 3, 4, 5, 6, 7, as like this, right, and E is a equal to 1.6 10 power minus 19 Coulomb, mean value of charge of one electron and one protons. This is a basic concept of the body charging method, and can be charged body by friction, by induction, and by frictions, by conduction method, right. This is a basic concept of the body charging method. When electron transfer from one body to another body, then individual both body becomes charged, but total charge of the whole system is conserved. This is a basic property of electric charge. Mean first property of electric charge, mean charge conservation. What is the concept of charge conservation? Mean total charge of the system is always remain constant. Total charge of the system of the system is always remain constant, right? Mean total charge of the system is constant, right? As like this, here total charge before charging body A having charge 0 and here charge 0 before charging, and after charging total charge of the system total equal to charge of A plus charge of B, and charge of A equal to plus NE, and here charge of B minus NE, and total charge equal to 0, because here amount of positive charge equal to amount of negative charge, and total charge of the system always remain constant, because we cannot generate or destroy electron means charge, only we can transfer electron from one place to another place, from one point to another, from one body to another body, cannot generate or destroy, only we can transfer electron, transfer charge from one body to another body, right? In the situation total charge of the whole system is remain constant, this concept known as a charge conservation law. And second property of electric charge, right? Second property of electric charge. Second property is electric charge mean quantization of charge. What is the logic of quantization? Quantizations mean, suppose that this is a body A and this is a body B, right? This is a and B. Before charging mean before transformation of electron, right? Before transformation of electrons, body A is a electrical neutral, because here total number of electron equal to number of proton and total charge equal to 0. And similar here before transformation of electrons, total charge of the whole system is constant. But when electron transfer from body A to B, then here individual becomes positive charge, right? Because here number of electron is less as a compared to number of proton, and here number of electron greater as a compared to number of proton, and here negative charge, and this is a completely negatively and this is a completely positive. And transfer number of electrons from A to B, transfer number of electrons, suppose that 1, 2, 3, 4, right, as like this. And here total charge of the body A and total charge of the body B is complete integral value of the transfer number of electrons, right, mean plus minus NE, and N is a transfer number of electrons, N is a transfer number of electron, and the value of N is a complete integral value as like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 similar, right. This is a concept of quantization of charge. And third property of electric charge, additivity of charge, right, additivity. What is the concept of additivity? Suppose that this is a distributed charge and here this is a body, and here distributed charge is like this, suppose that plus Q1 and here plus Q2 plus Q3 plus Q4, plus minus can be positive and negative, then total charge of the system equal to plus minus Q1 plus minus Q2 and similar as like this plus minus Qn. Mean total charge of the system is sum of all distributed charge, means sum of all distributed charge equal to total charge of the system. This is a basic concept of the basic property of the electric charge. This is a basic logic, right. Next topic for discussion mean Coulomb force, right, Coulomb force. Right. Suppose that this is a positive charge and this is a negative charge, and here plus Q1 and here plus Q2 separation distance r. In this situation both charge repel to each other as like this, because both are positive, And in the situations, Coulomb force is directly proportional to product of both charge and inversely square proportional to separation distance between both charge. This is equation first and equation second. From equation first and equation second, mean F is directly proportional to Q1 times Q2 divided by R square, mean F equal to K, capital K, Q1 times Q2 divided by R square. K is a electrical constant and value of K 9 10 power 9 Newton meter square per Coulomb square, and another value of K mean 1 by 4 pi epsilon naught. This value put here mean Coulomb force equal to Q1 times Q2 divided by 4 pi epsilon naught R square. And here epsilon naught is a permittivity of free space. Epsilon naught is 8.85 into 10 power minus 12 Coulomb square divided by Newton meter square. This is a permittivity of free space. Right, and this is a basic logic. Now some basic concept about the Coulomb force. Coulomb force is a valid only point charge, right, not valid for the distributed charge, right. And Coulomb force directly proportional to product of both charge, right, and inversely square proportional to separation distance between both charge. Mean Coulomb force is inversely square proportional to R, right, and like charge repel to each other. As like this, suppose that this is a positive and this is a positive. In the situation, both charge repel to each other, and suppose that this is a minus and this is a minus. And in case both charge repel to each other and unlike charge attract to each other, mean positive and negative. Suppose that this is a negative positive charge and this is a negative charge. In the situation, both charge attract to each other, mean like charge repel and unlike charge attract to each other, right. And this is a basic logic. Now Coulomb force in medium, mean fully medium, right. Suppose that this is a charge Q1 positive and this is a positive charge Q2, right, and medium field in this region, fully medium field. Then what is the value of Coulomb force? Mean Coulomb force in medium, mean Fm equal to Q1 times Q2, distance between both charge R, divided by 4 pi epsilon naught R square multiply K. K is a dielectric constant and also written as epsilon R. This is a dielectric constant of the medium, dielectric constant. Of medium, right, dielectric constant, and this is a unitless and dimensionless. This is a value of Coulomb force in medium, mean when fully medium filled between both charge of the between both point charge, right? And F0 mean F equal to Q1 times Q2 divided by 4 pi epsilon naught R square. This is a Coulomb force in air or vacuum, right? And this value put here. You can compare both equations, this value, right? Mean Coulomb force in medium equal to Coulomb force in medium mean Fm equal to F0 mean F divided by epsilon r. This is a basic relation between Coulomb force in medium and Coulomb force in air, right? And now we are discussed about when partially medium filled between both point charge. Here fully medium filled, right? But when partially medium filled between both point charge, then how to calculate value of Coulomb force between both point charge? Coulomb force mean value of Coulomb force when partially medium filled, right, between both point charge, as like this. Suppose that this is a point charge Q1, right, and this is a point charge Q2, right. Separation distance between both charge is r, and partially medium filled as like this. This is a slab of dielectric material and thickness of slab is T, and here T is less than as a compared to R, mean R is greater than as a compared to T, and dielectric constant of this dielectric material slab is epsilon r, or can be written as a small k. In the situation, how to calculate Coulomb force between both point charge as a given situations, right? Calculate this formula, mean Coulomb force Fm equal to Q1 times Q2 divided by 4 pi epsilon naught, and this formula most important for your exams, JEE and NEET exams, right? 4 pi epsilon naught r minus t plus t root k, k mean dielectric constant of the medium, and whole square. This is a result of this Coulomb force, right? This is a basic logic. Let us start next numerical problem related to the Coulomb force. Numerical problem of JPYQ, right? Suppose that this is an inclined plane, this is an inclined plane, and here positive point charge, right? Suppose that Q1, and here positive point charge Q2, and mass of this charge ball is m2, and mass of this charge ball is m1, and this is a angle of inclinations. Calculate value of mass m2. Find value of m2 for balance conditions. How to calculate value of mass m2? Mean mass of second charge ball. How to calculate according to given situations. Solve this problem, right? Initially we are divided component of this charge ball, and here component is a mg, mean m2g, and with respect to angle of theta divided two component, mean horizontal and vertical component as like this, and here component mean m2 g sin theta and here m2 g cos theta, and this component balance Coulomb force, and Coulomb force along this direction because both charge is positive and repel to each other, and repulsion force along this directions. Repulsion force along this direction mean repulsion force mean q1 times q2 divided by 4 pi epsilon naught r square. R is the separation distance between both charge. R is a separation distance. In this situation, we can say value of this force mean this is a charge body, and along this directions q1 times q2 divided by 4 pi epsilon naught r square, and along this directions m2 g sin theta, right, FBD of this diagram, this charge q2. For the balance condition, this force balance to this force, and mean m2 g sin theta equal to q1 times q2 divided by 4 pi epsilon naught r square, mean value of m2 equal to q1 times q2 divided by g sin theta multiply 4 pi epsilon naught r squares, right. This result most important for your exams, right. And let us start next numerical problem related to JEE exam. And next concept, question second. Suppose that here two charge ball as like this is a positive and the second is a positive. This is a charge q and mass m, and here charge q and mass m. Separation distance between both charge ball is r, and the length of the string is l, and this is the angle of theta, right. Find value of tension force on the string. Find the value of tension force on string, right. Find the value of. How to calculate this problem? Very conceptual solution of this numerical problem. Initially, we want to calculate the value of Coulomb force according to given situations, according to given diagram, right. Mean both charges are positive and repel to each other, and repulsion force along this direction mean q1 times q2 and both charge is a q, mean q square divided by 4 pi epsilon naught r square. Here r is a separation distance between both charge, and mass mean weight act vertical downward, and here divided component of the tension force, tension along this directions, and here angle theta because this is a theta mean t cos theta, and here t sin theta, and according to this given situations FBD of this charge ball along this direction force q square divided by 4 pi epsilon naught r square, and along this direction force t sin theta, along downward directions mg, and along upward direction t cos theta, and this force balance to this and this balance to this, and in this situations t sin theta equal to q square divided by 4 pi epsilon naught r square. If we want to calculate value of tension force on the string, then T equal to q square divided by 4 pi epsilon naught r square sin theta, right. And Next formula of the tension force, T cos theta equal to mg, mean T equal to mg divided by cos theta. And if we want to calculate value of angle, right, value of angle, then both equation divided as like this, mean T sin theta equal to q square divided by 4 pi epsilon naught r square, right. And second formula, second equation, T cos theta equal to mg, and divided mean T cos theta and here mg, right, mean cancel out T and here tan theta equal to q square divided by 4 pi epsilon naught r square mg. This is a basic logic, basic concept of the Coulomb force, right. And next problem of JEE mains exam. Suppose that this is a charge ball and charge q, mass m, similar, and the second charge ball positive, can be negative, right, no any problem here, polarity of charge, right, mean charge q and mass m, and both systems sink inside of the medium, right, as like this, right, as like this. This is a medium, this is a medium, and then find out value of tension force on the string, value of charge and value of angles for the balance conditions, right. Find a tension force on the string, right, find angle theta, right. Let us start step by step solving this problem. Very conceptual solution of this numerical problem, no any problem, very conceptual, right. Dielectric constant, mean dielectric strength of the medium, mean epsilon r is a dielectric constant, right. And here value of G effective equal to G1 minus density of liquid, right, density of liquid divided by density of solid. Here rho L mean density of liquid, mean this medium, and rho S mean density of solid, mean charge ball density of. This is a value of G effective, and here using the concept, this is a R and this is a along this direction Coulomb force, mean electric force, and along this directions mg, not mg, mg effective, right. And component of the tension force, this is angle theta, and here T cos theta, and along this direction T sin theta. This is a basic logic, and this force balance to this and this force balance to this, right, mean downward force balance to upward force and the left direction force balance to right direction force for the balance conditions, right. Mean Coulomb force Fe equal to balance T sin theta, and value of Coulomb force in Q1 times Q2 divided by 4 pi epsilon naught r square times k. K is a dielectric constant of the medium, dielectric constant of the medium, right, and equal to T sin theta, right. If we want to calculate value of tension force, mean T equal to Q1 times Q2, and here Q and Q equal to each other, then we can written as Q square divided by 4 pi epsilon naught R square K times sin theta. This is a value of tension force, right, and most important concept for your exams, right. And second concept, mean T cos theta balanced to mg G effective, mean T cos theta using different color, T cos theta equal to mg effective, and value of G effective equal to, mean T cos theta equal to m, and the value of G effective equal to G 1 minus rho L divided by rho S, and here rho L is a density of liquid, mean density of medium, and rho S is a density of charge ball, and rho S is greater as compared to rho L, right, mean density of solid is greater as compared to density of liquid. This is general concept, no any special logic here. Mean tension force T equal to mg divided by cos theta times 1 minus rho L divided by rho S. This is the value of tension force. Now, if we want to calculate angle of this angle, then both equation divided to each other, this equation and this equation divided to each other, and gets value of angles. Both equation divided means sin theta T sin theta divided by T cos theta, and here Coulomb force mean Q square divided by 4 pi epsilon naught R square K whole dividations mean mg 1 minus rho L divided by rho S, right, and here cancel out T from numerator and denominator, tan theta equal to here Q square divided by 4 pi epsilon naught R square K dividations mg 1 minus rho L divided by rho S. This is a value of angles, this angle, and a very conceptual logic here, no any difficulty here, right. For the next problem, right, this is a infinite charge rod, and positive charge distributed as like this, uniformly distributed as like this, linear charge density lambda Coulomb per meter, right, and Q naught point charge move along this circular path, mean around this charge rod as like this. Suppose that this is a charge rod and the positive charge point charge move along this path, mean around the charge rod along the circular path. Calculate value of time period of this charge. Find time period of charge object, right. Find time period mean T equal to question mark. How to calculate this problem? This is a charge ball, and here positive charge, and here uniformly distributed charge. Now calculate this problem. we from previous explanation, previous knowledge, mean electric field due to uniformly charged rod, here electric field E equal to lambda divided by 2 pi epsilon naught r, and r is a radius of the circular path, mean electric field due to uniformly charged rod. This is a value of electric field. And Coulomb force, mean force F equal to Q, mean charge multiply electric field. This is a value of electric force. This is a value of electric force. And for the circular motion, centripetal force act. This is a positive charge ball, and along this directions act Q naught E, mean electric force, and along this direction centripetal force mv square divided by r. And for the circular motions, both force equal to each other, mean centripetal force balanced to electric force. This force balanced to this force, mean mv square divided by r equal to mv square r divided r equal to q naught times E, and value of E put here, mean mv square divided by r equal to q naught lambda divided by 2 pi epsilon naught r, and r cancel out to each other. And for the calculation of time period, v equal to r omega and omega equal to 2 pi by t, right. And here put, mean m r square omega square, because v equal to r omega, and this r cancel out to each other, mean lambda times q naught divided by 2 pi epsilon naught. And for the calculation of omega square equal to lambda q naught divided by 2 pi epsilon naught m r square, and omega equal to square root of lambda q naught divided by 2 pi epsilon naught m r squares, and omega equal to 2 pi by t, right. Omega is a angular frequency, and here 2 pi divided by t equal to lambda times q naught divided by 2 pi epsilon naught m r square, and value of t equal to, right, 2 pi, and here 2 pi epsilon naught m r square divided by lambda times q naught. This is a value of time period when point charge move along the circular path as like this, right. This is a basic logic, because this force balanced to this force, mean q times E balanced to mv square divided by r. For the circular motion, both force balanced to each other. This is a basic logic, right. For the next PYQ problem, next concept. Suppose that this is a uniformly charged rod, and the charge distributed as like this, here charge q and linear charge density lambda and the length of the rod L, right. And from the r distance, second point charge q naught placed at point A. Find a Coulomb force on point charge q naught. Find a Coulomb force on q naught charge, right. How to calculate this problem? This is a basic logic, basic concept, because Coulomb force valid only point charge, not valid for the distributed charge, but here this is a distributed charge, not point charge. This is a point charge, but first charge is a distributed and second is a point charge, then directly cannot use Coulomb force. Here using some basic concept, basic logic, right, basic logic, right. We cut a small strip for the dx thickness and dq charge here, and this is a x distance, right, and this is a point charge, right. This is a point charge, means this is a point charge dq and thickness dx, and this distance is a x, and here point A and the charge q naught. Then now we can use Coulomb force here, because now here both charge become as a point charge, becomes work as a point charge, because this is a point charge and this is a also point charge, and here using the concept of Coulomb force, the logic of Coulomb force, mean Coulomb force between both charge, Coulomb force dF equal to, mean Coulomb force q naught multiply dq divide by 4 pi epsilon naught x square, and now we calculate value of dx, value of dq, mean lambda equal to dq divide by dx, mean dq equal to lambda times dx. This is a linear charge density, lambda, Coulomb per meter, right, Coulomb per meter, and here use this concept, mean q naught lambda dx divide by 4 pi epsilon naught x square, and now total force on q naught, right, mean integration both side df equal to integration lambda q naught dx divide by 4 pi epsilon naught x square, right, and here using limit from r to r plus l, right, because this is a r and this is a r plus l, because this length is a l, right. This is a lower limit and this is a upper limit. Here using the concept of integrations, mean f equal to lambda q naught divide by 4 pi epsilon naught and integration x power minus 2 dx limit from r to r plus l, and here using the concept of integrations, mean lambda times q naught divide by 4 pi epsilon naught, and formula of the integration, mean x power minus 1 divide by minus 1 from r to r plus l, right, and f equal to minus lambda q naught divide by 4 pi epsilon naught, because the formula of the integrations, integration formula, mean x power n dx equal to x power n plus 1, x power n plus 1 divide by n plus 1, and here 1 by x from r to r plus l limit. Using the limit and gets value of Coulomb force, mean minus lambda q naught divide by 4 pi epsilon naught, and here 1 by r plus l minus 1 by r, right, and this is a value of Coulomb force, right, according to given situations, according to given logic, according to given concept, right. And now we are discussed next numerical problem of the JEE mains exam. Next numerical problem related to JEE exam, right. Suppose that this is a non-uniform charge rod, right, and here lambda variable with respect to distance, mean lambda equal to a plus bx, right, and this is a non-uniform charge rod. Here charge density change with respect to distance, and similar numerical problem as like previous explanations. This is a distance r and here point charge q naught. In the situation, this is a length, this length is a L, and total charge distributed here q, and the linear charge density is lambda x equal to a plus bx, and a and b is a positive constant. Then find out value of Coulomb force on point charge q naught. Find value of Coulomb force on q naught as a given situations. Solve this problem, because here directly cannot use the formula of the Coulomb force, right? Because Coulomb force valid only point charge, and here first charge is distributed and also non-uniform distributions. Then directly cannot use the formula of the Coulomb force, mean k q1 q2 divided by r square, because this formula valid only point charge when both charge q1 and q2 both work as a point charge. What is the concept of point charge? If the size of charge ball, charge object is much more smaller than as compared to separation distance between both charge. Suppose that separation distance between both charge 1 meter and size of the charge ball is 1 mm 1 centimeter. In case we can say 1 mm is much more smaller than as compared to 1 meter. Then in this case we can consider q1 and q2 as a point charge, object, right? Using the basic concept, this is a x distance and this is a dq charge, and dq equal to lambda x and dx, and value of lambda x mean a plus bx multiply dx, right? Using the concept of Coulomb force, now this is a point charge, only this segment, only this segment, and Coulomb force dF equal to k mean electrical constant mean dq times q naught divided by x square, and integration of both sides mean dF equal to k, and value of dq equal to a plus bx dx times q naught divided by x square, right? And integration of both sides using the concept of integrations, right? And here value of f equal to here k times q naught and integration of a multiply dx divided by x square plus bx divided by x square divided by x square divided by x square, bx divided by x square times dx. Using the integration concept here both side, and here f equal to k q naught, and here integration logic mean integrations a x power minus 2 dx, and using limit from r to r plus L, plus here concept mean integration of b x power minus 1 dx, and using limit the concept of from r to r plus L, right? R plus L, and here integrations mean f equal to k times q naught bracket mean a divided by mean a times x power minus 1 divided by minus 1, because integrations formula x power n dx equal to x power n plus 1 divided by n plus 1 from this concept, right? And using the limit from R to R plus L. And similar here using the integration concept mean B ln x using the R plus L, right, R plus small l, and put value of the limit here and gets value of Coulomb force on point charge Q naught as a given situation, as a given diagrams, right. This limit put here very carefully and find the value of mean Coulomb force F equal to K times Q naught, and here minus A, and using the limit x R plus L small l and plus B, right, this is a bracket, and here ln R plus L divided by R. This is a basic logic of this formula, of this explanations, right. This is a basic concept, and here we are complete discussed about the Coulomb force and the different numerical problem related to this. Very conceptual explanations about the Coulomb force due to charge rod, due to uniform charge rod, due to non-uniform charge rod, and some different numerical problem of the JEE exam, JEE mains, and also NEET exams. This is a very fundamental lectures about the electrostatics and also Coulomb force. Thank you.